Hey everyone, while you guys are watching this ed puzzle and answering the questions, I also want you guys to either A, copy down the notes and upload them to Desmos, copy them down on Desmos, or send me a reminder of your notes, okay? I want you guys to make sure you have them because while you guys are taking your quiz, which is coming up next week, you will be able to use your Desmos or use these notes to answer the questions, all right? So the learning target is I can find the missing measurements when there is an incenter. So I have T as a circumcenter and I want to find RT. So right now what you guys are going to do is you're going to fill it out on Desmos and I want you guys to put your answer on the ed puzzle of what the length of RT is. So you guys are trying to find out this length, okay? In order to do that, we need to know what does it mean to be a circumcenter. So there's a couple of things that are congruent, okay? The length from the vertices to the center, all those are congruent. So if you notice, I have two equations, 4x minus 17 and x plus 10, and they are congruent, so I'm going to set them equal to each other. Okay, so I'm going to subtract x. I get 3x minus 17 equals 10. I'm going to add 17. 3x equals 27, and I'm going to divide by 3. X equals 9. Okay? Now that I have x equals 9, what you should have done is plugged it into one of the equations. It doesn't matter. When I plug 9 into here, I get 19. So I know that this is also 19, this is 19, and this is 19. Okay? Now I can find out the length of RT because I have a right angle here. Okay? So I'm going to use a squared plus b squared equals c squared. I'm going to get 14 squared plus b squared equals 19 squared. 196 plus b squared equals 361. I'm going to subtract 196. I get b squared equals 165. And I'm going to take the square root. So b equals 12.8. Okay, so pause me now if you need. Copy this down into Desmos, okay? And make sure you guys have the correct answer. So what you guys are learning today is about an incenter. So it's another type of center from in the triangle, okay? And what we know about the incenter is that the angle bisectors okay, of the angles of a triangle intersect at a point called the incenter. And the incenter is always equally distanced from the sides of the triangle. So let's look at this diagram. I have a few things that are congruent, okay? I know that I have angle bisectors, so my angles are congruent, okay? So angle A is split up into two congruent parts. Angle B is split up into two congruent parts. Angle C is split up into two congruent parts. So my angle bisectors in this case are PB, PA, and PC. Oops, sorry guys. Okay. The incenter is where they will meet, so it's at P. Now, I have angle bisectors, so if you remember when we did angle bisectors, we know that a few things are congruent, okay? So, list all the congruent segments. So the first thing that's congruent is that the incenter is always equally distanced from the sides. So that means that PD is going to be congruent to PF, which is going to be congruent to PE. So here, here, and here. They're always equally distant from the sides. Then with an angle bisector, I know that my sides are going to be congruent. So AD is going to be congruent to A. Ooh. Yeah. Okay. To AF. I know that CF is going to be congruent to CE. And BE is going to be congruent to BD. Okay, so copy this down onto Desmos. Now we know everything that is congruent inside a triangle that has an incenter, and we're going to use this information to answer the problems. Okay, so P is the incenter of triangle JKL. I know that MP is 8, LP is 13, and KO is 17. So from this last slide that we went over, we know we have congruent parts. I know that NP is congruent to NP, which is also congruent to OP. So if NP is 8, NP is going to also be 8. I know that KO is 17, so that means that NK is also 17. Now, I want to find out PK. So here's PK. So that means I have a right triangle. I have 8, I have 17, and I'm trying to find out X. So whenever we have a right triangle, we want to find out the third side. We're going to use A squared plus B squared equals C squared. Remember, my C is always across from my right angle. So this is 8 squared plus 17 squared equals C squared. We have 64 plus 289 equals C squared. 353 equals C squared. I'm going to take the square root. So C equals 18.8. And then last but not least, I want to find LO. Okay? So I have another right triangle. This is 8. This is 13, and I want to find out LO. Again, we're going to use A squared plus B squared equals C squared. In this case, we have 8 squared plus B squared equals 13 squared. 64 plus B squared equals 169. B squared equals 105, and I take the square root. B equals 10.2. Okay, so all I had to know there is what is congruent, and I had to do the Pythagorean theorem. Again, copy this down in your notes. Next, angle JKP. So I want to find angle JKP. JKP. I want to find that angle right there. So something that we need to remember is we have angle bisectors. And angle bisectors mean that I have two congruent angles. So I'm going to set them equal to each other. So x equals 5. Now, I'm going to take this 5 and I'm going to plug it in to find out what is the angle measures of my two given angles. So 7 times 5 minus 6 is 35, which becomes 29. So this angle here is 29. This angle here is 29. Just doing that is not enough, okay? Something we need to remember about triangles is that all my angles add to 180, okay? So this angle plus this angle plus this angle all equals 180. Well, I know what angle J is. Angle J is 29 plus 29. Okay. I can find out what angle L is because that's going to be 26 plus 26. Now, if you're asking where I got the other 26 from, because this is an angle bisector, both of those are equal. So I can find out angle K by adding these together, getting 110, and then doing 180 minus 110. So I get 70. So angle K equals 70, and this is the measure. Now, I only want part of angle K. So part of angle K is 35. I get that by dividing 2. Okay. So the measure is 35, I mean. Okay. I'm not going to do this last one. What I want you to do is really just make sure you have these two down pat for today. Okay. On Monday, what we're going to do is we're going to go over this. I want to kind of go over this a little bit together. And then you guys are going to do these practice problems on your own.